Example 6. Example 6. So let's say we have A is the vector 1, 2, 1, and let's say B is the vector 1, 4, 1, 1, 4, 1. Okay, let's go ahead and draw this out just for the heck of it. So we've got this vector here. Let's call that one B. Let's call that one A. So this is vector A. This is vector B. We know that the cross product is going to be a vector that's going to be perpendicular to both, and it's going to be coming out of the page if in fact, well, in this particular case, these are two vectors in 3 space, so we're just going to draw them out like this. This particular vector, which is A cross B, we don't know if it actually comes out of the page or not because we're dealing with 3 space, but it is perpendicular to both A and B. So let's go ahead and do our symbolic calculation. So A cross B equals I, J, K, and we have 1, 2, 1, 1, 4, 1. Okay. When we actually do this, expand it along the first row, we end up with the following. We end up with minus 2I plus 0j, and I hope that you'll confirm this for me because it's very, very possible that I made an arithmetic error. And in terms of regular coordinates, it is 2, 0, 2. So that's our vector. The vector itself is 2, 0, 2. And now let's go ahead and find its norm. So the norm of A cross B, well, it's equal to 2 squared plus 0 squared plus 2 squared, all under the radical, and that equals radical 8. So the length of this vector is radical 8. Its direction is perpendicular to both vectors. It is a vector. It has a magnitude and it has a direction. The dot product was a scalar product. It's only a magnitude. It's only a number. Okay, so let's go ahead and find the angle between those two vectors. So the norm of A is equal to radical 6 because it is 1 squared plus 2 squared plus 1 squared. And the norm of B is equal to radical 18, right? 1 squared plus 4 squared plus 1 squared. So now we have the sine of theta equals, I'm going to rearrange that formula, equals A cross B. Actually, you know what? I'm going to go ahead and stop there. I'm not going to do that. So that's what's important here, is being able to find the cross product given the vectors A and B, realizing that the cross product itself is a vector, and the direction of that vector is going to be given by the right-hand rule, where you take the first vector, A cross B, the first, swing it into the second. The direction that the thumb is pointing, that's the direction. The reverse direction is B cross A, and you can find the norm of the vector like you would the norm of any other vector. And it also turns out, if I draw a little parallelogram, complete the parallelogram for the vectors A and B, so this particular parallelogram that is spanned by the vectors A and B, that actually happens, this cross product, the magnitude of the cross product happens to be the area of that parallelogram. And of course, we'll talk more about that next time when we discuss surface area and things like that. Okay, so that's it for today's lesson, parameterizing surfaces and cross product. Thank you for joining us here at Educator.com, and we'll see you next time. Bye-bye.